Analysis of substitute goods is an essential part of answering several important economic questions. Much economic growth involves increasing the quality of the workforce, of capital goods, and of consumer goods. In these cases, the high and low quality versions of the product may be considered substitutes. In the competition setting, the products produced by two rival firms are substitutes. Alternative technologies can also be substitutes, as electricity and gasoline are for powering transportation equipment. A substitution relationship is indicated by a Hicksian cross-price elasticity. The price ratio model simplifies the analysis by assuming that the cross-price elasticity of a good with respect to its substitute is equal in magnitude to its own price elasticity. This implies that the demand for a good depends on the ratio of the prices of the substitutes. The Alkian-Allen effect is a notable outcome of this model. It suggests that an equal increase in the prices of two substitute goods will lead to a relative increase in the consumption of the higher-priced good. This happens because the price ratio moves closer to 1, effectively shifting consumption toward the higher-quality option. However, the price ratio model is quite restrictive. It assumes no substitution with other goods, which we can think of as a composite good. According to the homogeneity condition, the sum of the own price elasticities and the cross-price elasticities with respect to other goods must equal 0. Therefore, if there is some substitution between a good and this composite good, the cross-price elasticities with respect to the substitute must be less than the own price elasticities, violating the price ratio assumption. The price difference model offers an alternative approach. It posits that the cross and own price effects are of equal magnitude and levels, rather than in elasticities. In this model, the cross price elasticity is positive but less than the own price elasticities, violating the price ratio assumption. As a result, an equal increase in the prices of both substitutes does not affect the demand for the high-quality good, although it may still exhibit the Alkian-Allen effect by reducing the demand for the low-quality good. The price difference model also relates to a quality-quantity framework, where the utility function is expressed in terms of quantity, quality, and an outside good. Here, the price of quality is the difference between the prices of the high and low quality goods. This model allows for substitution to the outside good, unlike the price ratio model. As shown in Table 4-2, these models provide different predictions about substitution patterns. For instance, an increase in the price of a good in the additively separable model leads to some substitution to the outside good, a feature absent in the price ratio model. The price difference model, on the other hand, allows for substitution to the outside good when applied to high-quality goods. An estimate of the degree of substitution is required to assess whether two goods are substitutes and, if so, better modeled with price ratios or price differences. Hicksian symmetry and homogeneity are useful tools in this regard. If either good 1 or good 2 is significantly affected by the price of good 3, then that good's demand is not well represented by the price ratio model. Another approach is to look at the consequences of a compensated increase in the price of good 1. In the price ratio model, substitution is concentrated mainly between goods 1 and 2, with little diversion toward good 3. In the price difference model, there is more substantial substitution toward good 3. Using the partial elasticity of substitution definition, Table 4-2 also shows how each model of substitution ties own price elasticities to elasticities of substitution.